Hey, 2 months after this year's WWDC, I guess you've had enough time to play with the liquid glass redesign. I certainly have. Maybe you've even updated your apps already. But behind that big liquid glass announcement, there's a number of less shiny but arguably even more promising features and updates. And I feel that they shouldn't go unnoticed. In this video, I'll focus on what you might have missed at WWDC25. My list has overall improvements in privacy and security, additions to Swift's Interop with other languages, and a few really solid updates to some niche frameworks. If you find this video helpful, don't forget to give it a like and subscribe to the channel. Let's begin with something that nearly every app uses. I'm talking about networking. And let's have a look at how this year's updates make it even more robust even against next-generation threats. Maybe you know that since 2015, iOS and macOS require apps to use HTTPS when they make network calls. This feature is called App Transport Security. You can add exceptions to allow unencrypted connections, but HTTPS is the default. The use of HTTPS is supposed to protect the traffic from eavesdropping, which is really important when we're talking about user data. Simply using HTTPS was more or less sufficient back then, but the times are changing. More specifically, there's an important nuance that you should take into account going forward. The TLS protocol that's behind HTTPS mostly relies on what's known as classical cryptography. I'm talking about algorithms such as RSA or elliptic curve alternatives. These algos have offered robust security for the past 50 years. But again, the times are changing. Quantum computers haven't entered mass production yet, but they've already proven to be capable of breaking those classical algorithms. This danger is made even worse by the fact that storing data is more affordable than ever before. That means it's become quite feasible to intercept the encrypted data now and decrypt it later when quantum computing becomes more accessible. There's even a term for that: store now, decrypt later. And you can rest assured that hacker groups and nation-states are doing that right now. But the good news is that there's already a standardized set of post-quantum algorithms. They can protect the data from quantum computer attacks. And this year, the networking APIs available in iOS, macOS, and other platforms support some of them out of the box. Basically, all you have to do to take advantage of these updates is make sure you use the modern networking APIs and build your app against the latest version of SDKs. I can refer you to this WWDC session for details. Keep in mind, however, that securing the client app is only one part of the equation. To actually use post-quantum cryptography for networking, your backend must support it as well, including the latest version of TLS and specific modes of key exchange. Nevertheless, if you only work on client apps and have someone else to take care of the backend, then your task becomes much easier. You can simply rely on the updated SDKs to get the improvements in security. Unless you call low-level networking APIs or use custom protocols, then you don't really have to do much, it just works. But you know what wouldn't just work? It's Swift's Interop with other languages, which is the next item on my list. If you worked in any sort of multi-language environment, then you know that it typically requires some effort, and often considerable one. That applies even to the interaction between Swift and Objective-C. A few months ago, I made a video about the crucial differences between protocols in these languages. And protocols are just one aspect of many. Needless to say, mixing languages that weren't designed to be compatible from the ground up often turns out prohibitively difficult. That is why any additions that make Interop more approachable are a real lifesaver. Swift 6.2 ships improvements in two areas. First, the support for calling C and C++ code from Swift has been updated this year. It now offers safer access to memory. The strict memory safety compiler mode can identify and highlight potential errors in your code. And the new span types encapsulate C pointers. This helps you avoid the common mistakes of memory management. However, I'd say there's a much more exciting Interop update coming to Swift this year. With the help of some Interop tools, Swift can now interact with Java. But first things first. It is technically possible to implement Java methods in Swift even without compatibility libraries. That's because the Java compiler can emit C-style header files, but doing so is complicated and error-prone. That is why the Swift Java repo on GitHub offers a few missing middleware components. They include runtime libraries and build tools. This project is still a work in progress, but it promises two-way compatibility between Java and Swift. You can expose entire Java packages to Swift, and you can also call Swift code from Java. Even with the helper tools, there are some caveats, particularly with memory management. But anyway, the interop between Java and Swift is a big step forward. And to top it all off, a couple weeks after the conference, there was an announcement on the Swift forums. It's about the creation of the Android workgroup. Of course, this doesn't mean that you'll be able to run iOS apps on Android, or build Android interfaces using Swift UI. So it's not like KMP in reverse. However, if the work goes well, perhaps you'll be able to share some non-UI libraries written in Swift between the platforms. Speaking of things that didn't go well, if you had a chance to work with concurrency in the Swift 6 mode, you'll probably agree that this is not the easiest thing to master. Many teams decided to stick to Swift 5 for now, just because migrating their projects to the new version would be akin to writing it from scratch. So many things need fixing. Basically, those teams are just waiting until something changes. And hopefully, that something will change fairly soon. Even though the existing tools such as actors and tasks aren't going anywhere, it seems that the Swift development team has pushed the metaphorical reset button. In Swift 6.2, all your code runs on the main thread by default. That's it. This simple change should eliminate a large number of those concurrency warnings, the warnings that became errors in Swift 6. It's like having the main actor attribute attached to every class and method behind the scenes. If you want to enable concurrent execution, you'd have to opt into it using the concurrent attribute. This will tell Swift to run the code in the background. I can recommend you watch this WWDC session. It gives you all the essentials to start working with concurrency in Swift, even if you've never touched it before. In a way, you can just forget all those Swift concurrency articles that you've read and videos watched. I'm so glad I haven't done my own version, though it was on the roadmap. Sometimes being as disorganized as me has its benefits. It saves you a lot of effort. Okay, we've talked about security, concurrency, and interop. In other words, the serious and important stuff. I'll have one more security-related update at the end, but before that, let me tell you about the thing I'm personally most excited about. This one's perhaps on the niche side of software development, but as someone who often works with video, I find it to be my favorite announcement from this year's WWDC. Maybe you heard about the Video Toolbox framework. It's a set of low-level APIs for working with video. Its key feature is that it gives you access to hardware encoders and decoders, such as those found on the M-series chips or the older T2 coprocessors. And because Video Toolbox offloads the encoding to dedicated hardware, it doesn't slow down other parts of the system. You know what I'm talking about if you used Handbrake or similar tools to transcode your legally acquired MKV files. Well, this year Video Toolbox receives a bunch of awesome new APIs. You can use them to apply powerful video effects, including frame rate conversion, motion blur, and upscaling. As far as I can tell, all of them require an Apple chip, but it's hardly a surprise at this point. Personally, I'm mostly interested in motion blur, because this is what makes moving objects look more lifelike. I saw the examples shown by Apple, and I also tried this effect with my own sample clips. The results were okay, but you've got to understand the limitations. Realistic motion blur is quite difficult to get in post, especially for high-contrast scenes. And the graphics in my videos is mostly white text on black background. So here's a quick comparison. This is a keynote animation rendered at 24 FPS without motion blur. Each frame is crisp and sharp, but when they're combined together, the animation looks choppy. Here is the same video with motion blur added using Video Toolbox. I'd say the effect is somewhat noticeable, but it's not sufficient. Now, this is what I've been doing manually with the graphics in my videos. It involves rendering the animation at 60 FPS, then using frame blending, and finally applying the motion blur effect. It obviously looks better than no motion blur, and perhaps it looks better than the Video Toolbox result, though I'm not sure here. However, applying motion blur in post is still difficult, and that is why you sometimes get artifacts like this. And just for comparison, here's what motion blur looks like when it's added not to a finished video, but during the actual rendering. The movement looks much smoother, though you can find artifacts even here. Besides, this approach doesn't really scale. It took me 30 minutes to build this scene in Blender, plus 20 more minutes to render it. But not everybody cares about realistically looking motion blur. Perhaps more often you just want video to be sharp and detailed. That is the case when you're working on a video conferencing app, where limited bandwidth may result in low resolution or frame rate. Video Toolbox offers a couple effects designed to be applied in real time. For example, frame interpolation can generate the missing frames lost because of poor networking. And low latency upscaling may not be as good as the offline version, but it can still make the stream look sharper. These new Video Toolbox APIs are actually available since macOS 15.4 that was released back in March. But the big news from WWDC is that the same APIs are coming to the other platforms in version 26. That means you can take advantage of the new effects in an iPhone or even Apple TV app. Before wrapping up this video, I'll mention two more things worth paying attention to. One is the enhanced security mode coming to Xcode. It enables a few extra compiler and runtime checks to make sure your app is more difficult to tamper with. The implications of using this mode are quite significant, so you should test and debug your builds really well before you release them. And the final thing I want to highlight is this session about privacy-centric app development. It does mention a few specific APIs and tools, but more importantly, it reminds you of the key principles of privacy-oriented software design. I believe it's an important session, especially this year, and I wish more companies adopted those principles. That's a wrap for this Codebird episode. If you found it helpful, give this video a thumbs up and subscribe to the channel. This year, I decided not to release a WWDC digest in a rush. Instead, I took some time and looked beyond the liquid glass. As a developer, I realized this redesign will be used by many millions of people. But as a user, I don't find it very appealing. Speaking of a redesign, or more accurately, rebranding, I decided to rename this channel the Codebird because this name aligns better with my approach to software development. Swift is a great language, and Swift content isn't going anywhere from this channel. But I always treated technology as a means to an end, not the end per se. Programming languages, frameworks, design patterns, and whatever. To me, they're just tools for creating something of value to real people. And if maximizing the value to real people requires using a different language or framework, I don't think that should become a showstopper. With that said, I'll see you in the next Codebird episode. Until then, make your tools fly.